the Science Guy. Bill Nye the Science Guy.
Science rules.
Welcome, day 2 and day 3. Since you're going to have to use the information, your observations and evidence from day 2 to answer day 3's question, was the demonstration a example of chemical change or physical change? You might as well do them the same day, all right? Not too much to do. You're just watching, making some observations, and then answering the question, is it a physical change or a chemical change, REPP format. So what I would do is watch a demonstration, listen to my observations, pause the video, and then write down the information in the data table that is found on the doc. You're going to add it to the first column, all right? And then day 3's assignment is for the second column, which is answering the question based on your evidence, is it physical or chemical change? This is one of my favorite days of the year, all right? Definitely my favorite lessons to teach. I get to be up here doing science stuff, all right? You guys get to be out there in the classroom or behind your Chromebook or iPad or Mac or whatever, your tablet, watching the demonstration. And hopefully you'll still be as amazed as you would if you were in the classroom. Remember, our anchor phenomenon we're trying to answer is, how do glow sticks glow? Our guiding question for today is, how can I explain the differences between chemical change and physical change through observable evidence? Observable evidence. There we go. Instructions. During the video, you will be paying close attention and observing several different ways that matter interacts. You can collect observations and evidence and add to the data table below. Listen to what I have to say and make your own observations as well. I'm not going to say all the observations. I want you to add your own observations so you get a good idea of what's going on. You'll be making the final claim if the reaction was a physical or a chemical change, and use your evidence to support your claim. You will then turn in the doc to day 2 when you're done after day 3, all right? You still have an assignment for day 4 and day 5, weekend homework. Oh yeah, compliment Friday, and always be active, okay? To help you better understand, let's review a few things that we have covered in class. Matter is everywhere around us, okay? Anything that takes up space and has mass is matter. The air between me and the computer screen is you, there's matter between us, all right? You look anywhere around your room and you're looking at matter, all right? Any object is matter. Atoms and compounds that are combined to make up matter. So we have atoms, molecules, compounds, elements combining to make up the matter that is around us. Those atoms go on to build things that you see and touch every single day. Matter is defined as anything that has mass and takes up space. Since the beginning of Earth, or since the beginning of time, all matter that was on the Earth has simply been changed from one form to another. All mass on the Earth has simply been changed from one form to another. Mass cannot be created nor destroyed. Matter cannot be created nor destroyed. So if it's losing some kind of energy, all right, it's gaining something else. It's losing mass, it's gaining something else. Somewhere else, another substance or another object is gaining its mass or its energy, okay? Endothermic, exothermic, we'll talk more about that later on. You observe several substances change either chemically or physically when you watch the following demonstrations up here. But first, a word from Mr. Sulini on safety. Mr. Sulini here to talk to you about safety. Whether you're dealing with sharp objects, loud noises, chemicals, or fire, It is always important to be safe. Having the proper safety gear can really save your life. Currently, I have this lab coat on to protect my clothes from any chemicals, or also adds another layer of defense. I wear these gloves when I'm working with chemicals so that they don't get on my skin. These goggles protect my eyes so that I can see for the rest of my life. And I'm also wearing ear plugs. I left my heavy duty ones at school, so it protects my ears and my hearing from loud noises. All right, thank you, and be prepared for the demonstrations. Hey, welcome back. All right, we are down to demo time here. Thank you to Mr. Sulini for the safety tutorial. We got to make sure we are keeping our eyes safe during these experiments and demonstrations so that we are safe and sound and can return home. We are going to be taking a couple of observations from all of these demonstrations. All right, so whatever you see during the observation is what you're going to be writing down. I'm going to be saying some, adding some of my observations. You are to add on to those, just making sure so that everything is all crystal clear. Physical changes, all right? Physical changes is a substance that does not change. It could change shape, it can change size, it can change state of matter, all right? A couple of examples of physical changes: me ripping up the cotton ball, breaking up a candle, maybe the candle even melting, all right? Because it changed from a solid to a liquid, it's still the same, made up of the same stuff, still the same chemical bonds, and it is still the same substance. So that's a physical change. Chemical changes is when something changes, when a new substance is produced, okay? When there is a change, could be a change of state, change of color, change of state, as well as physical change, but the difference is something is being produced, okay? Smoke was produced, a flame was produced. That is the difference between chemical and physical change. So keep that in mind as we go through these demonstrations. Demo 1 and 2 I have done for you with the observations. What I am going to color this white cotton ball. I'm going to color it up. It's changing its color. It's changing its shape. It's kind of changing its size, I guess, but it's still the same substance. It's still cotton, okay? So this would be a physical change, all right? So what I would say for this, I'll look at my notes, is a cotton ball. It was white, cotton, dry, and in a ball. It turned purple. It's no longer dry, and it's in, we'll say, many pieces, okay? My final claim, this is what you do for day 3, is based on the substance changing its color, texture, shape, and size. I think it is a physical change, okay? So number 2, burning the cotton ball, all right? Burning the cotton ball, since I'm dealing with fire, you gotta get some safety gloves on. It's a white or purple-ish cotton ball, and I'm going to add some flame to it, okay? Put it down here. And that is a chemical change right there, okay? You can see the cotton ball burning. I might let it burn for a little bit, and then we're good to go, okay? Once it's all burned out, we'll move on. So a couple of the observations that I'd make for number 2, burning of a cotton ball, is it is a white cotton ball with blue or purple on it from my first demonstration, turned into flames. I could definitely smell there is an exothermic reaction going on here because heat is being released, and the ball turned into black ashes with black smoke being released. The smoke is a product, the flame is a product, so, and therefore it's a chemical reaction, okay? What my final claim would be, based on the substance changing its color, texture, shape, and releasing a smell, smoke, flame, and turning into a different substance, ash, this is a chemical reaction, all right? Chemical reaction. Now, moving on. So this is the time for you guys to start adding the observations that I say, okay? Make sure you pause between each demonstration to add your couple pieces of information, all right? So, crushing a can, no longer need the gloves for now. All right, can of bubbly. Okay, I'm going to put it right here, crush it. This reminds me of playing my one of my favorite games, kick the can, with my cousin back in the good old hockey days. But you can see that the shape of the can has changed. Definitely the appearance has changed. It's the same can, you know, made of the same substance. So that's a hint for the final claim. You can move it, you can mess it around. Smaller, probably I would say the same mass. And that's all we have for the third matter interaction, okay? Fourth matter interaction, homemade snowball, all right? So I have 3 cups here, all right? 3 cups, 1, 2, 3, okay? And I'm going to add water to one of the cups, okay? It's a little windy out here, so I want to make sure that everyone can see. I'm going to add water to one of the cups right here, all right? And I know, you all know that I'm magic over here, okay? So now what I'm going to do is see if you guys can guess what cup the water is, okay? Just to give you double insurance, it's in this cup. So I'm just going to move it around. Let's see what we have here. Oh. All right, what cup is it? You got it. It's in this cup right here, as you can see. Just like that, all right? Let's see it again. Let's try it again. See if it's in this cup, or guess what cup it is in again. Almost dropped it. Very good. What cup is it? Yep, you got it. I almost gave it away. It's in this cup, okay? Let's try one more time. All right, so what cup is it in now? This one? You sure? Ah, I got you right here. Nothing in that one. Nothing in that one. Nothing in that one. So where'd it go? Good question. It's actually in this cup, all right? This is sodium polyacrylate, all right? It's a polymer. This is a polymer, and what this sodium polyacrylate can do is absorb 200 to 300 times of its mass of water, okay? This stuff is made for your diapers that you guys wear. It is also made for to be put in gardens, and you know, in all the movies I stunt in, it's in my it's made for fake snow, okay? So that's why we have a homemade snowball, all right? Number 5, all right? Number 5, grind and anvil part 1, okay? Grind and anvil is something that Mr. Sulini had mentioned about Mr. Ray and Mr. McCollum. They shared a lot with me when my first 3 years of teaching down in Warsaw, Indiana. So shout out to them. When I did this, I did a science show, and it was I did it during a science show, and the science show was amazing. They had a rich history with that stuff, and it was very fun performing during the science show, all right? But this is a simple grind and anvil. It is sulfur and potassium chlorate, and I've had some mixed up here, but I'll show you. Here's some sulfur. Want to make sure I'm using different spoons so we're not mixing these chemicals. All right, here is the potassium chlorate, all right, even amounts, and then we are going to mix them up, grind them up. The sulfur is yellow, okay, the potassium chlorate is white, all right, and so I'm just mixing up these two chemicals, okay. The color has changed a little bit. The potassium chlorate is being turned into a lighter yellow color, and this is what you see, okay? we're gonna put this aside for now and use this at a different date, or a different time rather, all right? But that's the observations that I would do for number 5, grind and anvil part 1. All right, next one, wash your hands. Okay, here we go. I have water over here. This one's pretty easy. That I just dropped, love it, gotta love it. Okay, water in that one, and in that Petri dish, and water in this Petri dish. So we have just water in this. This is plain H2O. I'm going to put some pepper on this water. Due to the surface tension of water, something we've learned previously, the pepper flakes are floating atop of the water. The cohesion of the molecules is allowing the surface tension to be stronger and not allow the pepper flakes to sink. Okay, in this water I'm just adding a couple drops of soap. All right, the soap, I'm gonna mix it up. Okay, this is what happens when I put the toothpick in the water with pepper. But this is why washing your hands is so important, okay? Because when you have soapy water, all right, the soap of the water is going to break the surface tension, allowing the soap to clean all the bacteria off your hands. And this is what happens when you add soap to the water. All right, you can see that the pepper flakes are now along the edge, and I see some of them that are sinking. I'm not sure if you can see it right there, but you can see how the pepper flakes kind of move to the edge and the surface tension is broken. I'll try it again. That one wasn't as good. One more time. You want some salt with that pepper? I think it's done now. All right. Sweet. Next, iodine clock. All right. The iodine clock. We're gonna deal with some chemicals here. All right. The iodine clock is something, well, believe it or not, that I haven't done. So, wish me luck with this. All right, the iodine clock. I'll move all that over to the side. What the iodine clock is, in cup A, we have grounded up pieces of vitamin C. Okay, grounded up pieces of vitamin C, and it's just a fine powdery substance. And I'm going to add 60 milliliters of water. I got my water back here. Got to get good, accurate measurements. That's way too much, figured. $60 milliliters of water right here in cup A. All right. We'll stir this around a little bit. I'll get my toothpick. Stir it around, try to dissolve all of the tablets in the water. And yeah, these there's 1,000 milligrams of vitamin C in here. You can take 2 tablets a day to boost your immune system. All right, it's good for you, especially in time that we're in now. Okay, you gotta stay healthy. You gotta keep your immune system top tier, so you don't get sick. You also got to wash your hands. All right, so vitamin C in this one. In this, we have iodine. All right, we have iodine, 1 teaspoon of iodine. That is what is in here. Okay, and I'm just going to add another 60 milliliters of water. Okay, iodine and water. It's just all that is in here. Got to get accurate measurements. Okay. Stir this up a little bit. Oops. Stir this up a little bit. So in A and B, this is what we have here, okay? All right, you can see A is the color is like a cloudy white,
color. This is more like a tannish brownish color. Iodine, who knows what iodine is used for? Yes, you. Yeah, you're right, exactly. It is used in the medical field. You put iodine on cuts, and the surgeons know where to cut, and it gives sterilizes and cleans the area as well. All right. So I'm going to put 1 teaspoon of A in B. That's it. Right here, 1 teaspoon of solution A and solution B. See what's happening? I'll try to put a little bit more. Alright, so it's not only, there we go. So you can see that the brown substance is turning a yellowish color. I'm mixing it up a little bit, and it's eventually turning white, okay? There it is, all right? So usually there would definitely be some sort of residue left over, some kind of a brown color, but the color is completely white now. I am not doing any tricks other than my magic science tricks that I had, excuse me. Now in cup C we have liquid starch that goes on our clothes, and we have 15 milliliters of hydrogen peroxide that I put right here. Alright, so we have hydrogen peroxide, liquid starch, and I'm going to add another 60 milliliters of water. And what I'm going to do, I'm getting pretty good at this measuring thing. What I'm going to do is I'm going to pour our B solution that has A and B in it, and I'm going to pour it in here. Let's see if I can use a bigger cup. All right, yep, should have planned for that. So this is basically C solution. I'm going to pour B right here, and I'm going to just let this sit right here, and you guys are going to watch this as I continue. All right, I'm going to let's put a nice dark background behind it so you can see, and let me know when something happens to that. All right, hopefully you guys can see that. All right, next is acetone and styrofoam. All right, acetone and styrofoam's right here. Buckeyes, you can't beat them, you got to destroy them. All right, right here, as the styrofoam is interacting with the acetone, the styrofoam is being eaten away. The styrofoam is going to dissolve in the acetone because styrofoam is made of mostly air. It dissolves and becomes kind of a silky or slimy material or substance. All right. Hopefully, I'll show you how that works. It's a pretty easy demo, and I believe you guys have seen it anyways. Back in the beginning of the year, around Christmas time. So what's next here? All right. So we got a couple of things. We have grind and anvil part 2. So what I'm going to do is I'm going to add my mixture that I added, sulfur and potassium chlorate. I'm going to add it right here. All right, so that's quite a lot of mixture. And so what is going to happen now is I'm going to add a little bit of heat to it, and you guys are going to see what happens. Okay, so this is a light yellow color. What happened before was just a example of a physical change, hint hint, nudge nudge, and now I'm going to add some heat to it and see what happens here. Ta-da! All right, so that was a reaction. Okay, what happened? Was anything released? Was there anything released? Was there anything that changed? All right, I saw some smoke, some flame, definitely color change, and to name a few things, okay? So let's see. Let's have a little bit more fun with this stuff, all right? If some is good, more is better. Wise words of Mr. Ray and Mr. McCollum. So we're gonna do that right there. I'm gonna add just a little bit more. I don't think you guys need this part. I accidentally broke it. So, as you see, the top dot is what I poured. If a little is good, more is better. Boom shakalaka. All right, let's see what we got here. So instead of adding heat to it, I'm going to be adding pressure. All right, and in order to be safe, as Mr. Sulini said, you need earplugs. So I'm going to put my earplugs in. Can you hear me? What? Huh? All right, sounds about right. Can't sound anything. Can't hear anything. So, what we're gonna do, instead of adding heat, we're gonna add some pressure, okay? I'm gonna push this back a little bit. And we're gonna go from there, all right? You ready? One, two, okay. You guys might want to plug your ears at home, okay? Plug your ears at home. It is a good idea to do so, all right? One, two. All right, so what happened there was the chemicals had reacted, okay? When I added pressure to the mixture, the expansion of gas, the product, expanded from the brick through the air, okay, contracting through the air into the speakers, from your speakers through your air and into your ears, all right? So that's how that works. Also, what the potassium chlorate and sulfur makes is fireworks, okay? So the firework that we have on display today is right behind me, all right? And since I am going to be lighting it off, it is during the day, so you can see the rest of this, but I'm sure you know what a firework looks like, but let's see how sulfur and potassium chlorate reacts when it's professionally done. That's what it looks like, folks, all right? So the same stuff in that firework is what we were just, the demonstration was. So you can use your evidence for the Grinding Anvil Part 2/firework to prove your final claim, all right? So we're good with that. Now on to our finale, all right? So right here, we have a couple of things going on. All right, there is hydrogen peroxide, the stuff that we put on our skin for when we have a cut, okay? There is also soap, about 15 milliliters of dish soap, food coloring, blue food coloring, go blue, all right? And that is all that is in here, okay? If I had seen something like this before, hopefully we don't make a big old mess. That's not gonna happen, all right? Now, what we have in this one is 25 milliliters of water and about 5 grams or so of potassium iodine, all right? So I'm going to simply add this into here, and we are gonna see what is happening, all right? We don't need the water anymore. Around for safety. By the way, here is the final product of the styrofoam. It just took a little bit for it to occur. Sometimes reactions don't happen instantaneously. Chemical and physical, including physical reactions, happen over several minutes, years, thousands of years. I mean, think about the mountains, okay? The mountains have eroded, weathered. That's physical changing, okay? It's physically changing, okay? So as the rivers, the landscape, all right, those are all physical changes. There is chemical changes when the minerals and elements react with certain minerals and elements with the water and the air. That's how the oceans got salty, through the salinity, the sodium in the rocks. But for the majority, the weathering and erosion is physical erosion, physical change. All right. So this is the styrofoam and acetane. All right. That's what happens here. There's kind of a slimy substance down here that is collected at the bottom. I would say this is a physical change. I'll help you out with this one since it didn't work as I thought it would. The styrofoam had deteriorated away, leaving behind this slimy substance, and it got smaller. The substance is still the same substance, okay? The styrofoam is still the styrofoam, even in its slimy form. It hasn't produced any new substance, so that is why it's a physical change. All right, so on to our last one. Let's see what we have here. Goggles on. Like I said, this is number 10, elephant toothpaste. We have potassium iodine in water in this small beaker, and then hydrogen peroxide, soap and food coloring in this big beaker. All right, let's see what happens. Wow, I know there's a little different setting there, but it still occurred. All right, that is elephant toothpaste. Hopefully you guys were able to see some changes. All right, definitely expansion of the material, an explosion everywhere. You hopefully have seen that before. I'm sure you have, especially if you've been in my STEM class. And that's all we have here for physical and chemical changes, evidence, observations. Make sure you pause each or after each demonstration if you have to go back and watch it to add to your final claim. All right. Have a great week. Be safe. Stay active. Be cool. See ya.